Hello everyone. Now in this video we are going to learn about amino acid. So as you can see here we have two subtopics for this chapter. We have 12.1 which is the introductions about amino acids, and of course the second one usually like what we always learn, chemical properties of amino acid. Now let's see what is amino acid. So as you can see, amino acid has it's a compound with two functional groups. Okay, it has two functional groups, and the first one is carboxyl, which is COOH, and the second one is amino, which is NH2. So this is the general structure of alpha amino acid. As you can see, we have this carbon. Okay, we have this carbon attached with amino and the carboxyl group. Okay, it has one H and R. This is general structure of amino acid. Okay, so given here alpha amino acid. So what is alpha amino acid? As you can see at the next point, it is an amino acid which has carboxyl and amino groups that bonded to the same carbon atom. So you see, same carbon atom. Okay, so this is alpha amino acid. Now, naturally there are 20 amino acids, and you have to at least remember all these 20. Okay, and fun fact about amino acid is that amino acids, they are optically active except glycine. So we will see about this later. All right. So from the general structure, okay, let me see again. So like I said, this is your amino. Okay, this is your amino. And this is your carboxyl. This is your H, and this is your R. So the R could be anything. Okay, the R could be hydrogen or alkyl group or OH or R with ACE. Okay, so let's see. Now, if your R here, okay, if this R is replaced by H, it is known as glycine. Okay, it is known as glycine. Now, if you remember just now, I mentioned that glycine is not optically active. Why? Okay, let's okay, let me show you. Now we have NH2, C, then we have C double bond O, OH, and we have H here. Now, if your R here is replaced by another H, now you can see that this carbon is no longer not a chiral carbon. Okay, so this is glycine. Glycine is not optically active. Why? Because it has no chiral carbon. Okay, so that is for glycine. But the rest of the amino acid, they are optically active. Now, if your R is replaced by methyl, then the amino acid is known as alanine. Okay, so you can see we have some of valine, we have leucine, isoleucine, phenylalanine, serine, threonine, tyrosine, cysteine, methionine, and dot. Okay, what else we have? We have asparagines, we have glutamine, lysine. Okay, this is very famous among parents because it is a vitamin that can help the kids or the toddler grow. Okay, jadi kuat makan as well. Now we have arginine, we have proline, tryptophan, histidine, aspartic acid, and glutamic acid. So do you need to know all these common name? Better you know. Okay. However, in exam they will give you this common name together with the IUPAC name. So when you have the IUPAC name, at least you know how to draw the structure very well. So talking about nomenclature of amino acid, beside the common, we also are going to learn about the IUPAC name. So to give name to the amino acid according to the IUPAC rules. So let's take a look first. Actually, this is the way we are going to give the name of it is just the same as how we name the carboxyl group, because as you can see we have carboxyl and amino, and of course according to the priority, carboxyl will become the parent chain. Okay, so for example, like in this structure, which is glycine, so we are going to find the parent chain first. So of course the parent chain is this, and together with this carbon. Now, secondly, we are going to number it. This is carbon number 1 and this is carbon number 2. And therefore, our amino is located at carbon number 2. So, the IUPAC name for glycine is 2-amino ethanoic acid. Okay, 2-amino ethanoic acid. Okay, let's try alanine. So of course, this will be part of the parent chain. Try to find the longest chain, so it can be this. So we have here 3 carbon. Now if we give numbering, this will be carbon number 1, carbon number 2, and carbon number 3. Our amino is located at carbon number 2. Therefore, the name of this structure is 2-amino. We have 3 carbon, right? So this one will be propanoic acid. Okay, let's try again some more. Okay, we have valine here. Let's see, have this as the parent chain, 2, 3, and 4. Oops, 4. Okay, so 1, 2, 3, 4. So our amino is at carbon number 2. Our methyl is at carbon number 3. Methyl amino. Amino comes first because amino is A. So the name of this structure is 2-amino 3-methyl 1, 2, 3, 4 butanoic acid. And let's try leucine. Okay, let's number them. 1, 2, 3, 4, 5. So amino is located at carbon number 2, and we have another methyl located at carbon number 4. So the name for this structure is 2-amino 3, oh sorry, not 3, but 4-methyl 1, 2, 3, 4, 5 pentanoic acid. Okay, let's see another. Okay, this is isoleucine. 1, 2, 3, 4, 5. So we have this, and we also have this one. Carbon number 1, number 2, number 3, number 4, number 5. So the name is 2-amino 3-methyl pentanoic acid. Okay, let's see, phenylalanine. 1, this will be your first carbon as usual. Okay, so this is the longest chain. So 1, 2, 3. 1 and 2. So this is phenyl. Okay, in case you guys forgot, this is phenyl. So the name will be 2-amino, 3-phenyl propanoic acid. Okay, next one is serine. Okay, so this one will be carbon number 1, 2, and 3. So our substituent will be amino and hydroxyl. 1, 2, 3. So the name will be 2-amino, 3-hydroxyl propanoic acid. Okay, easy, right? Okay, so let's go for threonine. I will just go through all the amino acids. Okay, do not worry. So this is the longest chain. This is our substituent. Carbon number 1, number 2, number 3, and number 4. So the name would be 2-amino, 3-hydroxyl butanoic acid. Okay, and the last one is aspartic. So we have this, carbon number 1, 2. Oh, we have 2 carbon here, 2 carbonyl here. So we have 1 substituent. Okay, we have 1 substituent. So what will be the name for this? Okay, the name for this is, okay, so we have 2 carbon, 1, 2, and so we have 1, 2, 3. Okay, we have 3 carbon. Okay, we have 3 carbon, and this one will be 2-amino. Okay, 2-amino. This one propan dioic acid. That's how we give name to the amino acid in IUPAC rules.